Artificial intelligence course for beginner by knowledge and information. In this video we are discussing about Part 3, Computer Vision. What is computer vision? Computer vision is a field of study that focuses on enabling computers to interpret and understand visual data from the world around us, such as images and videos. It involves developing algorithms and techniques that allow machines to analyze and interpret digital images and videos, and extract information from them that can be used for various applications, such as object recognition, facial recognition, image segmentation, and more. Computer vision is a subfield of artificial intelligence, and it is becoming increasingly important in a wide range of industries, including healthcare, automotive, entertainment, and security, among others. With the advent of deep learning and other advanced machine learning techniques, there have been significant advances in the field of computer vision in recent years, enabling machines to perform tasks that were once thought to be the exclusive domain of humans. Some of the key applications of computer vision include: (1) Object recognition. This involves teaching machines to recognize and identify different objects in images or videos. This can be used in applications such as autonomous vehicles, where the vehicle needs to be able to detect and recognize other cars, pedestrians, traffic signs, and other objects in its environment. 2. Facial recognition. This involves teaching machines to identify and recognize individual faces in images or videos. Facial recognition technology is used in a wide range of applications, from security and surveillance systems to social media platforms and photo management software. 3. Image segmentation. This involves breaking down an image into its constituent parts, such as individual objects or regions of interest. This can be used in medical imaging, where doctors need to identify and analyze specific structures within the body, or in satellite imagery, where analysts need to identify and monitor specific features on the Earth's surface. 4. Augmented reality. This involves overlaying digital information on top of the real-world environment, in real time. This can be used in a wide range of applications, from gaming and entertainment to industrial design and training simulations. One of the key challenges in computer vision is dealing with the variability and complexity of real-world visual data. Images and videos can vary widely in terms of lighting conditions, camera angles, background clutter, and other factors, which can make it difficult for machines to accurately interpret the data. To overcome these challenges, researchers in the field of computer vision have developed a wide range of techniques and algorithms, including: 1. Convolutional neural networks, CNNs. These are deep learning models that are widely used for image and video analysis. CNNs are designed to learn spatial features from the input data, and are capable of detecting objects and patterns at multiple levels of abstraction. 2. Recurrent neural networks, RNNs. These are deep learning models that are used for sequential data analysis, such as video analysis. RNNs are designed to learn temporal features from the input data, and are capable of modeling the dynamics of a scene over time. 3. Object detection algorithms. These are algorithms that are designed to detect and localize objects in images or videos. Object detection algorithms typically use a combination of feature extraction, classification, and regression techniques to identify and locate objects of interest. 4. Semantic segmentation algorithms. These are algorithms that are used to segment an image into regions that correspond to different object classes or semantic categories. Semantic segmentation algorithms typically use deep learning models to learn features from the input data, and are capable of segmenting complex scenes with high accuracy. Computer vision techniques and algorithms are typically based on machine learning models, such as neural networks, which are trained on large datasets of labeled images and videos. These models are designed to learn patterns and features from the data, and to use this knowledge to make predictions and decisions about new images or videos. One of the exciting recent developments in the field of computer vision is the use of generative models, such as generative adversarial networks, GANs, and variational autoencoders, VAEs, for image and video generation. These models are capable of learning complex patterns and features from large datasets, and can be used to generate new images and videos that are realistic and visually appealing. Another area of active research in computer vision is the development of models that are capable of learning from limited or noisy data, such as small datasets or low-quality images. This is particularly important in applications where collecting large amounts of labeled data is expensive or impractical, such as in medical imaging or remote sensing. In addition to its applications in industry and academia, computer vision also has important implications for society as a whole. For example, facial recognition technology has raised concerns about privacy and civil liberties, and there is ongoing debate about the appropriate use of such technologies in law enforcement and other applications. However, the development and deployment of computer vision systems also raises important ethical and societal issues, including concerns about bias, privacy, and the potential misuse of these technologies. Bias can be introduced into computer vision systems if the training data is not representative of the full range of diversity in the population, leading to incorrect or discriminatory decisions. Privacy concerns arise when computer vision systems are used for surveillance or monitoring, potentially infringing on individual rights to privacy and freedom of expression. Misuse of these technologies could have serious consequences, such as the use of facial recognition to target specific groups of people or to suppress dissent. To address these issues, there is a growing need for interdisciplinary research and collaboration across the fields of computer science, ethics, law, and social science. Researchers in computer vision and related fields must work to ensure that their work is conducted in an ethical and responsible manner, taking into account the potential social and ethical implications of their work. This includes promoting diversity and inclusivity in the development and deployment of computer vision systems, ensuring transparency and accountability in the decision-making processes of these systems, and engaging with stakeholders to understand their concerns and perspectives. Overall, computer vision is an exciting and rapidly evolving field that has the potential to transform the way we interact with the world around us, enabling machines to see, understand, and interpret visual information in ways that were once thought to be impossible. Computer vision is a highly interdisciplinary field that draws on expertise from computer science, electrical engineering, mathematics, and other disciplines. With the continued growth of digital imaging and video technologies, computer vision is likely to play an increasingly important role in many areas of our lives in the years to come. Computer vision is a rapidly evolving field that is poised to have a profound impact on many aspects of our lives. By enabling machines to see, understand, and interpret visual data, computer vision has the potential to revolutionize industries ranging from healthcare and transportation to entertainment and advertising, and to transform the way we interact with the world around us. In summary, computer vision is a rapidly advancing field that has the potential to transform many aspects of our lives. However, the development and deployment of these technologies also raises important ethical and societal issues that must be carefully considered and addressed. By working together across disciplines, we can ensure that these technologies are developed and used in a responsible and ethical manner, for the benefit of all. In next video, we will discuss about applications of computer vision. Thanks for watching. Please like, share and subscribe.